Welcome back to ECSJ 2020 from Trieste. I am happy to introduce you Professor Martin Bauer, Director of the Master Course in Social and Public Communication at the London School of Economics and Professor of Social Psychology. Martin Bauer is a researcher, and his research is particularly focused on the relationship between science and common sense through theoretical elaboration and comparative research using national surveys, mass media monitoring, and also qualitative inquiry. But for us as a science journalist community, I think that the most interesting part of his research is the analysis of public controversies he did and his current work on the so-called scientific cultures, how local scientific cultures can shape the public discourse on science. So I'm really glad to welcome Martin Bauer, and thank you for attending our conference and allowing us to hear your thoughts about science cultures and the role of science journalists. Martin, the field is yours.
I hope one can understand my voice from here. I think we tested this out. I'm very glad to be here at this opportunity at ESOF. Needless to say, I would prefer to be there in person. But this is the unfortunate situation, so we have to kind of resort to this mediated form of giving a talk. But anyway, I appreciate the opportunity to talk briefly about our research on science cultures. And I will want to do that maybe in two steps, a few preliminary remarks, and maybe juggling one or two metaphors of how to do that. And then I would like to explore with you three ways of reducing the varieties of cultures of science. And in the answer to the question, how many science cultures there are, I have to say I don't really know yet. Certainly more than one, and that's the key point, but probably less than 100. And the question is, how do we constrain this variety on a global scale? And what we might do in order to get this kind of orienting knowledge, and why this might be important. Now, I'm trying to share my document now. I hope this works. I guess this works now. Does this? Yes, this is visible. So I will talk through this in measured time. So my main point starts with a kind of an axiom that science is global, but science culture remains local. Science culture in that sense is a matter of mentality, and mentalities are probably not global, and they probably will never be global because they are historically rooted and have many different contexts to be taken into account. So let's start from this. The first implication of that is that we might have to make a distinction between scientific culture and science culture. This might be useful for us. Scientific culture is in principle the culture of conducting science, of doing science, the culture of laboratories, the culture of creating a scientific community, and the culture of talking within the scientific community, the kind of debates one has in there. This is a scientific culture. This is a very elite group. That's probably in the area of 5 to 10% of the population maximum, or even less in most places. On the other hand, we have the majority of the population who somehow more or less puzzled pays attention to this scientific culture, but does this from a point of view of a science culture. They're kind of people imbibing elements of this, have been educated into science at primary school, secondary school, some even further than that. But they are not part of the scientific culture because their daily life is not creating laboratory tests or producing scientific papers. So I think that's the first distinction, and they have different contributions in society, which is this yin and yang image. They're kind of hanging together like a yin and yang. Let me deploy another metaphor, which I developed in conversation with our Chinese colleagues, where the world is very different. from Europe in many respects, which is this idea that we are dealing with a problem that might be best exemplified with the London Roadmaster bus. The London Roadmaster bus is well known as a red bus, a double-decker, but it has kind of three useful elements for us. It has a bus driver, which I would call the scientists. These are the scientists who drive the scientific culture in one or the other direction. This is a scientific workforce, working conditions, there is hardware, and there are certain styles of doing science, either experimentally, observational, and so on. And then there are road conditions, and these are the funding streams, the career prospects, and so on, that kind of support the bus drivers. But most importantly, and for our purpose, is in principle the back seats, the people in the passenger seats, both at the lower level of the bus, but also the top. And in England, we have this famous saying, the crucial thing is what the man and the woman at the upper deck of the Clapham omnibus are thinking about matters. And this is also matters about science. So people will talk, people have access to science in one way or the other. They do that from their own point of view. They display loyalty. They display suspicions. They display enthusiasm. They voice concerns, and they might even just leave it all alone. Now, the ambition my research group or my research program for many years has to create a kind of an index, a science index system of science culture. Needless to say, this is not work I do myself, but this involves a bit of traveling. It used to involve a bit of traveling, and I hope we can resume this, because one can't do science culture studies globally from a desk in London. This is impossible. So one actually has to interact with many people around the world, and here are some of them. To name would be too many to list here, but I will come back to this later. So our index system consists in principle of three constituents. We are worried about large-scale survey research, measuring attitudes or public understanding of science, PUS. We're also measuring attention that is given to science, and in principle is the call of the science journalism community, among others, who draw attention to interesting or problematic elements of science. This creates media monitoring, or opportunities for media monitoring and media studies. And last but not least, there are opportunities where the man and the woman of the top of the Clapham omnibus have opportunities to meet scientists or to see science in action. These are case studies of encounters between the marvels of science and the general public. We call this PES, public engagement with science. So in principle, an ideal system would have something to say about all these. Let me just briefly say something about attention. Clearly, attention to science is not a constant. This is an attempt of measuring this over the last 200 years. And you can see here, this looks a bit like global warming. It goes up and down. It has certain periods of above average coverage of science compared to other news, religion, sports, theater, and so on. But in the last 20 or so years, there's clearly an enormous hike in attention to science in all respect. However, a few years ago, we tried to update this data with many outlets in Europe: Süddeutsche, Mirror, Times, El País, Times of India, Corriere della Sera. It looks like that in the mid-2000, early 2000, this might have reached a little peak, but we don't want to go not further on that. Who provides this attention to science? Who draws attention to science? This is a mix of people, needless to say here, among the science journalists, a crucial team of doing this since the 1950s, professionally organized in many countries. But previously, scientists have done that, and they're coming increasingly back doing it themselves with blogging and other things. But then there is also the public relations officer at the research institution or the university that takes care of making sure attention is being cultivated. And we have also forms of activism, that whatever the angle is of that activism, it draws attention to science. If the activism is about vaccination, if it is anti-vax, whatever one might take on that. It is drawing attention to something where science has its competencies. The same can be said about global warming, environmentalism, and things of that kind. So the constituency of drawing attention to science is kind of shifting over time. Again, needless to say, among communicators, to communicate better, know your audience. That's an old wisdom, since Aristotle at least. In our case, we want to kind of characterize the particular science culture on a continental level. When we talk globally, continents might be significant, on a national level, on a regional level, or even on a personal level. So here I come to the crutch, this idea of a 3D plus model of science culture. And I'm trying to make sense here to the audience what the 3D plus might mean. The 3D is what we suspect might be a common framework that might carry globally. That we have relations to things and therefore also to science as an activity, as an institution, that is marked by 3 dimensions. In the European, in the Greco-Roman context, we know this as knowledge, feelings, and appetite. It goes back to Plato's image of the chariot. Now, Plato imported a little bit of a problem for us with that, because he suggested that knowledge is kind of in charge. It kind of should and is in command of the 2 horses, feelings and appetite. This is, I think, more an empirical question than necessarily a metaphysical a priori. But the interesting thing for us thinking about science culture is that such triads of dimensions of relationship to things in the world have also resonance in as you go along the axial, the Silk Road, for example, into Persia or in India. We often find this kind of triplets, and we certainly have the modern triplets of knowing, feeling, and having a kind of a behavioral tendency. So these are this is the bedrock within which we want to reduce the variety of science cultures. But how might one possibly do that? Not to be overdone in speculation, we need a kind of an empirical material within which we can test this. And over the years, science cultures in many cultures or scientific community have generated data of a national representative kind. In other words, national representative surveys or opinion polls about how people relate to science and technology. Now, this is only the databases general. And you can see here, this is a global map. This started in the 1970s in France in 1972, one of the first surveys on public attitudes to science. And then it kind of globalized around the world. In North America, obviously, is coming in, picking this up quickly and quickly leading. And then it moved into Asia and into Latin America. So this curiosity about public attitudes to science created this data stream. And what we want to do with our attempts of creating indicators is kind of to look at this data, maybe with fresh eyes, because these data indeed are not have not only one interpretation, the interpretation under which they were constructed and commissioned at the time, but maybe they lent themselves to a new interpretation in the light of 3 dimensions of attitudes. So we find in this data, and that's interesting, we find similar questions that address the promises of science. P, what we call evaluation number 1, what does science promise? Which can then be frustrated, or people can adhere to this and see this is indeed happening. Science and technology makes our lives easier and more comfortable. A very old Enlightenment promise, a 18th, 19th century promise what science will bring, an easier life, a more comfortable life. Second, we have evaluations of a reservation kind. Concerns about science. We depend too much on science and not enough on faith, a certain dilemma between religion and science, or science and technology is just making our lives change too fast. This kind of sense it is part of a revolution and we don't want to turn so quickly. It also can represent the kind of secular impatience, a conflict between science and tradition. Secondly, we have indicators of interest. People are very variably interested in scientific topics, either moon landings or sending rockets to the Mars or the latest discoveries of species. This can draw attention, and this can adhere. This can attract interest, or this might accommodate interest. And then we have engagement questions. People do certain things to satisfy their interests. So they go to a science museum, or they attend a regular television or a radio program, or they have a regular diet of hashtags in relation to their particular scientific interest. And last but not least, people are more or less steeped in this large corpus of what is called scientific knowledge and scientific vocabulary and scientific concepts. So these are the famous knowledge items. So having all this at our disposition, we can do various things with that. This is what we call the PREC: promise, reserves, evaluation, and knowledge. These are the 4 dimensions, basically 3 dimensions, but the promise, the evaluation element is split between promise and reserve. And let me now unfold maybe another metaphor, a kind of a food diet. How do we describe the food diets across different places in the world? A first attempt might be to consider the ingredients. They might indeed be global: salt, sugar, fat, and carbs. So maybe there's some more, but let's just work with 4. So the first way of characterizing cultures might be in this way, with levels. So you can compare basically the different levels and do kind of rank orderings, and you can even see how these things change over time. So we can show, for example, that knowledge in Britain, Germany, and France over the last 20 or so years seems to be increasing. Adherence to the promise of science in Britain seems to be not increasing, but kind of leveling. And in Germany and France, there's an element of disenchantment with science happening. Reservations is leveled in Britain and Germany, decreasing. So this basically shows, once you think about pure levels of any of these indicators, they can go up and down over time, and this is either synchrone or asynchrone between different national regions. This can go across Europe, and we can see here that creates quite a bit of variety here. This is Eurobarometer data. Knowledge in yellow, engagement in gray, reserves in R, in orange, and promise in blue. And you can see there might be a little bit of covariation, and this is what we're trying to understand. So here is promise, color-coded Europe. The promise is highest in the purple countries, and belief in promise is lowest in the more reddish countries. Reservations are highest again in the purple countries and lower in the reddish countries. Engagement is higher in the purple and lower in the reddish. Knowledge, again, higher in the purple and in the... As you can see already that these things are not going in one single direction, everything being correlated in the same way. And the same we can do for China, just to increase the complexity and ask the question, now because we are in collaboration with Chinese colleagues and we have Chinese data from all Chinese provinces, 65,000 interviews every 5 years, we can do again a similar mapping of the Chinese universe. And then the question is really now, how is the covariation between these 4 intensities, high or low knowledge and so on, coming out? And this is a possible attempt now to reduce this into, here we have probably 6 possible cultures, taking into account not only China, Europe, but also taking into account Indian provinces, so the large 3 continents that we have data accessible. And the question would really be, in which company is a particular country located? So I highlight here Italy, in honor of the fact that we are in Trieste. Italy here is part of that green, seem to be slightly an outsider, and not in a direct company with, for example, Switzerland or Germany or Romania, which is in the red circle. Now, this is just a kind of a first reduction. Obviously, we haven't really understood yet why this is the case and what does really mean. That would be the next step of validating this. One can even go one further technically and see how this might change over time. And here is taking into account different countries in different years. And these branches identify, again, closeness of the variation between these 4 dimensions. And again, Italy there is in company with Ninja and Neimongo and so on, rather than in company of European countries. But what that means, again, we would have to kind of carefully look into. We also have a possibility for the last few years to have suddenly global data available. 144 countries provided by the Wellcome Global Monitor. In 2018, focused on vaccination hesitancy, but it also had questions on promise of science, on engagement with science and familiarity with science, and then obviously the vaccination hesitance is a matter of reservation. And you can see here how this stacks up as a matter of, as a function of GDP, maybe linear, maybe none. Promise clearly is not necessarily in a direct relation to GDP, while knowledge is. A vaccination hesitancy, as we well know, is complicatedly related to development in that sense. Now, that's the first one. You simply worry about the ingredients and how they stack up, how much knowledge, how much promise, and so on, and you try to order countries in that way. But as we know, the crucial thing about the diet is not how much sugar, but how sugar goes together with other things, how they get together with different ingredients, how they are mixed. So progress, reserves, engagement, and knowledge. How is progress and reserve, generally speaking, stacking up in a region? How is knowledge and engagement stacking up? So in principle, we have 6 correlations possible between these 4 indicators. And already on a very global level, we can see here that in Europe, this is a factor map, which basically shows if these key dimensions stack up on one line, they mean they're correlated, either positively or negative. So, for example, in Europe, E and K are highly correlated. So that's where they are close together on that line. And R is on the same line. So reserves in Europe is also correlated, but opposite. So high knowledge, high engagement seems to be correlated with low reserves. But none of these things, it seems to be correlated with promise. So promise might take the belief in the promise of science might take its source from somewhere else, not from engagement, from knowledge, or from having reservations or no reservations. While in China, this stacks up slightly different. Knowledge and reserve are exactly opposite. They're highly correlated. Who believes in the promise does not have any reservations, and the other way around. And knowledge seems to be independent, or this evaluation of science seems to be more or less independent of any level of knowledge. And engagement seems to suggest to become more correlated with P. So on a very macro level, you already see how these variables are stacking up slightly different in these different contexts. Now we can go a little bit further into detail. So in Europe, our first attempt to the OECD a few years ago, we suggested that Europe might have 4 cultures of science. A cluster number 1, either you love it or you hate it, which is nearly a kind of a traditional scientific literacy model. A cluster number 2, you love it and you worry about it at the same time. Or be indifferent or ignorant. A cluster number 3, you love it and hate it, and knowledge makes very little difference. And a cluster number 4, where there is very little relationship between these indicators. So any combination seems to be available, and none of them is particularly dominant. Worries or interests or knowledge interests do not in any way combine. And that gives a kind of a map, a heat map. That's the first way of reducing this European diversity of mixing and combining these particular forms of relating to science as a correlation. So PR stands for the correlation between promise and reserve, promise and engagement, and so on. And if we reduce this, we get a kind of a map of 4 color shades. So the love it and hate it is a little bit towards the northeast Europe. If you the anything goes is further towards the east, the former east. The love it and hate it in both versions we'll find in the Balkans and towards Turkey more prevalent. Interesting is this particular indicator, the correlation between promise and reserve. So a high negative correlation, like here in Sweden, means people who believe in the promise of science, they have very little reservations, or the other way around. While if you go to the countries of Odi et Amo, the ambivalence, you love it and hate it, this famous Roman poem by Catullus, I think. You could see here that, for example, Turkey, Greece, Bulgaria, you have this very strong correlation between believing in the promises of science, but at the same time having reservations, or none of this at all, in that sense. So that's it seems to be an interesting indicator whether you have ambivalence or whether you have either or relationships. It correlates, as it seems, that's the first way of validating this, with innovation index. This is the innovation index, the European Innovation Index. So the higher the correlation between P and R, the lower the level of innovation, as it seems to be. That's a kind of a first attempt to show that this is not kind of a random variation. If you can do the same thing for China, again, in China we seem to deal mainly with 2 clusters. Again, it can be characterized in this way, and we create a map. Now here is a way of creating the same branching map on the basis of correlations. And you can see here, Italy is in company with Cyprus, Greece, and Turkey in 2005. And if we combine the time dynamic, the temporal dynamic, you can see that Italy changes its company here in 2001, here Italy in 1992, and here Italy in 2005. So here we have a kind of a trajectory through the forest of attitudes to science of a particular region, and that is something one would want to see. So we see not only absolute levels, but movement relative to each other. As I said, this is very much work in progress. This is just a way of reducing the complexity of the data, and we need to do now we need to obviously do some validation work. And as one always does in research, when he's looking for the adequate funding, actually to pay full attention to this kind of material. The last idea is that you can have a personal diet. Somebody might generally be steeped in the Italian diet, but on the whole prefer some things over the other. And this again we can do. So we have here the 4 dimensions, and we can basically say high and low on either of them and make types. And you can see this gives 16 types. It's like a personality type, 16 PF. Some of you might know that. You have 4 personality dimensions, and you combine them all, and it gives you kind of 16 different types of how this might combine. Again,
sorry, Martin.
We need to stop. Yeah, okay. That's fine. It's just going through one more time. This is another opportunity here. You get variation, and you get clusters, and we can play. So what? What is the significance of this? In principle, these attitudes to science, they represent trust and reputation in science, presence of science in everyday life. And as we know, reputation of science depends on the reputation, or the reputation of science in crisis depends on how the reputation is stacking up before the crisis. So in principle, these indicators might give us an indication of how robust these reputations might be. This might all relate to the particular model. For those who want to read a little bit more of where this work in progress is, there are 2 publications, an early one and a later one with a bit more results. So thank you very much. Merci, grazie, obrigado for this opportunity. Sorry for being too late, but I'm happy to take questions or now or later. Thank you very much. Over to you, Daniela. Thank you very much.
Thank you very much, Martin, for this very interesting talk. There are a few questions. We have a few minutes, but I read the first one from Patrick Wilson. Wow, some really interesting reflection here on regional identity and emotional response to science and maybe life. Martin, to what extent are these attitudes a reflection of language, emotionality of expression? We Northern Europeans are famously repressed.
Okay. I mean, I'm trying to avoid. I am trying to avoid this old game of national stereotypes for the moment, but they might at some point become relevant. Clearly, surveys are language-based, and they reflect kind of the way the formulation is happening. There might be micro variations, but I think this is an attempt of trying to capture a bit of diversity and getting away from the one best way, from the one single model fits all, for the one shoe fits everything. That's, I think, as far as I want to go for the moment.
I have another question from Eleni. Shouldn't we look separately at science as the body of scientific knowledge and its advancement, and at science as the academic orthodoxy? Trusting in the process of science and trusting in what relevant authorities say are two different things.
Yes, probably true, yes. As we know at the moment, there is a lot of claim to scientific evidence, even from governments, and the scientific community tends to disagree or whatever. Clearly, in the detail, one has to tell, but in principle, that's again an interesting feature of scientific culture. To what extent such a distinction is relevant? I would make it an empirically indicate to what extent this is a significant fact that people recognize the difference between science and government in all circumstances. Not so clear in China, I presume. Okay.
Another question by Blanca Berzosa. What's your opinion about citizen science? Do you think it could improve scientific culture? Do you think involving citizens in somehow doing science could improve citizenship trust in scientists, or rather the other way around? If anyone can do science, then it may not be that valuable.
I mean, citizen science is both an aspiration, it's an ideal, but it's also a practice. A citizen science, like I become a citizen science if I observe birds in my garden and fill in a form for the Royal Society for Protection of Birds. But it's also an aspiration that everybody in principle should be potentially a scientist. It goes back nearly to Napoleon. Everybody has the general in his pocket, so to speak, the baton of the general in his pocket. Everybody can make this move, and then it's a kind of a democratic ideal. All of them are relevant, and citizen science activities in principle would be part of our third indicators: possible engagements, encounters, opportunities for encounters between science and society, and therefore giving the society an opportunity, or members of the public an opportunity to form an opinion on the basis of some, however remote, experience of doing science.
Okay, we are a little bit late, Martin. I want to thank you very much for this inspiring talk, because as science journalists, we always think that and actually it is our duty to stick to facts, and we think that facts speak on themselves, but actually what you are talking us, and maybe we should be aware from the studies from social psychologists and social communication, is that facts are received in very different way. I mean, they are not as objective as we would like as science journalists. So I think that your studies are really interesting for us, and I hope we will have another opportunity to interact, maybe in person in the future.
I very much hope so. Thank you very much for giving me the opportunity.
And for
thank you.
Thank you again, and for all the attendees, in 5 minutes we have a plenary roundtable, Filters for Truth. Will artificial intelligence replace reporters and fact checkers? Stay with us. We have a 5 minutes break. Thank you very much again.